Okay, we're looking at the Unit 1, Lessons 4 through 6 practice quiz. First question we have is directions are just to simplify. The question has 7i squared times 6i. So the first thing I did was I squared 7i and I got 49i squared. And then multiplying that by 6i, 49 times 6 gives me 294. I squared times I is I to the third power. And I to the third power simplifies to negative I, so my answer is just negative 294I. Second question, again I need to simplify here. Simplifying a 7 plus 2i times a 9 minus 6i means that I need to FOIL. So I FOILed and I got 63 minus 42i plus 18i minus 12i squared. And remember that I squared is negative 1, so negative 12 times negative 1 is positive 12. I combined my like terms, negative 42i and positive 18i, to get negative 24i. And then in the final step, I added 63 and 12 to get 75 minus 24i as my final answer. For question 3, it says the impedance in one part of a series circuit is 1 plus 3j ohms. And the impedance in another part of the circuit is 7 minus 5j ohms. Add these complex numbers to find the total impedance in the circuit. So the key here is we've got two numbers and we need to add them. So we're adding complex numbers. You're going to add the real parts, 1 and 7, to get 8. You're going to add the imaginary parts, 3j and negative 5j, to get negative 2j. So your answer is 8 minus 2j ohms. Question 4 says we need to find the value of c that makes each trinomial a perfect square and then write the trinomial as a perfect square. So the process for this is we look at the b value, negative 20. We're going to divide it by 2 and then square it. So negative 20 divided by 2 is negative 10. Negative 10 squared is 100. So c is 100. And then rewriting it as a trinomial and then the perfect square, you just say x minus whatever b over 2 is, which was negative 10, so it's x minus 10 squared is this simplified way of saying x squared minus 20x plus 100. Question 5 said to solve each equation using the square root property. That means we're going to have to square root both sides and round to the nearest hundredth, which is 2 decimal places if necessary. So looking at this, the first thing I noticed was that this is a perfect square because 25 is 5 squared. And 10 is 2 times 5. So I can simplify this to just say x plus 5 squared, because we have 5 squared that gives us 25 and 2 times 5 gives us the 10. Then I'm going to square root each side, so that gives me x plus 5. And then the square root of 16 is 4, but remember you have to put plus or minus. Then I'm going to bring the positive 5 to the other side. It's going to be written negative 5 plus or minus 4, and then so you have to find your two answers from there. Negative 5 plus 4 is negative 1, and negative 5 minus 4 is negative 9. So those are my two answers for question 5. Moving on to the back. Question 6. We have to solve the equation by completing the square. So when I look at this, the first thing I notice is that 19 is not a perfect square, so I move it to the other side. You can see I do that here. It becomes negative when you move it to the other side. Then I'm going to look at my b value of negative 14. I'm going to take half of it, which is negative 7, and then square it. That gives me 49, so I add 49 to each side. Then this is a perfect square. It's x minus 7 squared, because remember again, 7 squared is 49, 2 times 7 is 14. And negative 19 plus 49 is 30. Then I square root each side, so I'm left with x minus 7 on the left, and plus or minus the square root of 30. And I just left it as square root of 30 because I can't factor that. It's 3 times 10, but neither of those is a perfect square, so that doesn't help. It's 6 times 5. Neither of those is a perfect square, it doesn't help. It's 15 times 2, but neither of those is a perfect square, so that doesn't help. So I just leave it as square root of 30. And then I want to bring the negative 7 over to the right side, so it becomes positive 7 plus or minus root 30. And those are your two answers for number 6. Number 7, we're going to solve using the quadratic formula. First step, make sure everything is on one side. So I'm going to bring the 3 to the left side. It becomes negative. I'm going to write down a, b, and c, 3, 8, negative 3. I'm going to plug them straight in the formula. I'm going to simplify. You can read through this as the steps. The key is when I get over here, negative 8 plus or minus 10 over 6. Negative 8 plus 10 is 2. 2 over 6 is 1/3. Negative 8 minus 10 is negative 18 over 6. Negative 18 over 6 is negative 3. So my two answers are 1/3 and negative 3. For question 8, we've got x squared equals 4x minus 15. And again, we're using the quadratic formula. So again, we need to move everything to one side. This time I brought the 4x to the left, so it became negative. And I brought the negative 15 to the left, so it became positive. So my a, b, and c are 1, negative 4, and 15. Then I plug all the numbers in. Make sure you're careful with this, otherwise you're going to make lots of mistakes. I got negative 44 inside the square root. The negative inside the root tells me there's going to be an I in my answer. I'm going to have imaginary answers. 44 I can break down into 4 times 11. This is my 4, this is my negative 1, this is my 11. The square root of 4 is 2. The square root of negative 1 is I. And 11 I can't break down, so that stays by itself. Then what I did was I did 4 over 2 and I got 2. And I did 2i over 2 and I got just I. So we have 2 plus or minus I root 11 for my two answers. Question 9. Complete parts A through C. So part A, find the value of the discriminant. That's b squared minus 4ac. Part B, describe the number and type of roots. Part C, find the exact solutions using the quadratic formula. So part A, the discriminant, b squared minus 4ac. My A is 4, my B is negative 3, my C is negative 6. I plug those numbers in and I got 105. Because that's positive, it tells me for part B that there are going to be 2 real solutions. And then part C, finding those 2 real solutions, I plug them in the quadratic formula. I plugged my A, B, and C in. I got 3 plus or minus the square root of 105 over 8. You can leave it that way, or you can write it as 3 over 8 plus or minus 105 root 105 over 8. Last question, question 10. The formula D equals 0.05 s squared plus 1.1 s estimates the minimum stopping distance D in feet for a car traveling s miles per hour. If a car stops in 200 feet, what is the fastest it could have been traveling when the driver applied the brakes? The fastest it could have been traveling means they're asking me to solve for s. So I have to solve for s. That means I must know D. The distance is 200 feet. Make sure you write that information down, pull out the important information. Plug the 200 in, bring everything to one side, and then find the solutions for s. So that means the easiest way probably is using the quadratic formula. I plugged all the numbers in. Obviously this is going to be some weird looking numbers because we got decimals that we're squaring and multiplying and dividing by. When I did that, I simplified everything down. I got negative 1.1 plus or minus 6.4195 divided by 0.1. So negative 1.1 plus 6.4195 divided by 0.1 gave me 53.2. And negative 1.1 minus 6.4195 divided by 0.1 gave me negative 75.2. So now that you have these two answers, you have to use your brain and think a little bit. What's the fastest it could have been traveling? Can a car travel at negative 75 miles per hour? No, that's illogical. Don't use this answer. Use the answer that's positive. So you want to say, for your final answer, the fastest the car could have been traveling is 53.2 miles per hour. Make sure you have a positive answer, otherwise this problem makes no sense. Okay, that's the whole practice quiz for Unit 1, Lessons 4 through 6.